Good morning, this is Dr. Franklin Nolan. We are covering the study of Enterprise Java Bean by Emmett Ravi, December 2005, from the California State University, Chico. Ravi's master's thesis can be found at QA 76.Bravo4928/2005. We're coming to you September 18th of 2005 here at the Sacramento State Community College. The study of Enterprise Java Beans is going to be found at the Chico State Library on the second floor, and the barcode number that can be picked up is 3//OT/16//6603. Barcode as follows. Scan. I'm going to cover the reference and bibliography of this master's thesis. I've browsed it and read it past couple days. It's pretty good. It's 2005, so it's very current. Our references are as follows. We are covering 16 references. Look them up as we go through the presentation. Go ahead and cite those references as needed. PRN, and I'll cover the index, table of contents, the acknowledgments, and the abstract. So reference 1, we're going R1's Happy Enterprise Java Beans, Cambridge, MA, Riley and Associates. 2, Sun Microsoft Systems Incorporated, Java 2 Platform Enterprise Edition, J2 Echo Echo, Java Technology 2005, retrieved March 4th, 2003, from World Wide Web, java.sun. And I'll just read off the titles because we've done so in previous recordings on this particular thesis. So 3B Kawan Java on the web for Servlet JSP and EJB Minneapolis. New Writers 2002. Fourth, we've got Sun Microsoft Systems once again, compatibility. That's from 2005. Internet reference is good as well. 5, Sun Microsoft Systems. Again, Enterprise Java Bean Technology, that's 2005, also found at the same site. 6, you got E. Roman, S. Amber, T. Jewel, and F. Borenskew. That's the Masters Enterprise in Java Bean, New York, that's 1999. 7, Object Management Group Incorporated, homepage, 2005. That is retrieved 2003, down on the reference listed before. 8, Sun Microsoft Systems, Java Naming and Directory Interface, JNDI. That's Core Java, and that is 2005. Reference can be found in the previous lesson. 9, we have Sun Microsoft Systems Incorporated, Java 2 Platform Standard Edition. That is J2SE. Java Technology, that's 2005. Reference can be found using the link from the previous. Reference 10, Sun Microsoft Systems, Java Messaging Service, JMS, Java Technology, J2 Echo Echo, 2005 as well. Sun Microsoft, reference 11, Sun Microsoft Systems, Java Servlet Technology, Java Technology, that is J2 Echo Echo 2005. That is retrieved 2003. I'll skip that, I'll just tell you where the sources are. You can find it yourself on the 2 previous recordings. 12, D. Allure, J. Coopery, and D. Marks Core, J2 Echo Echo Patterns. 13, we're working with Sun Microsoft Incorporated, JDBC Technology, Java Technology, that is reference J2 Echo Echo 2005. 14, we're working with G. Shashadri, Understanding Java Serving Page Model 2 Architecture Exploring MVC Master Design Patterns. 15, we're working with Sun Microsoft Systems again, this time Java Mail, Java Technology, that is J2 double echo 2005, and that can be cited at the same location as the other Sun Microsoft Incorporated sites. And the final reference, 16, we're going to do, once again, Sun Microsoft Incorporated Java Server Interface. That's Java Technology, cited at J2 double echo 2005. So just refer back to the other two lesson plans for this. Information is listed below. We're going to pick up where we left off. This is study of Enterprise Java being the project presented to the facility of California State University, Chico, and partial fulfillment of the degree requirements, Master of Science in Computers by Emmett Ravi. Very good presentation, summer 2005. He's done very well for himself since. So can you. So go ahead and stick your head in this. Table of contents, listing of tables, list of figures, abstract. We're working with 5 chapters. 11. Project overview, architectural overview, resource management and prime services, entity beans, session beans. Session beans is chapter 5. Message-driven beans, airline reservation system technology overview, future scope and development, and then references. So the breakdown of each chapter, to pick up where you left off. 1. Project overview, introduction, YEJBs, project purpose, project scope. 2. Architecture overview. We have the enterprise bean component using enterprise beans, the bean container contract, the contract server contract. 3. Thirdly, third chapter, resource management and prime services, resource management prime service. And 4th, entity beans. 5th, we have session beans, stateless session beans, and stateful session beans. See the contrast between the two within that chapter. If you want to skip to that after the first chapter, or skip to it in reference to having that information lock in and knowing the difference between the two, is very helpful. Get that down in the beginning. We're doing 6 message-driven beans, and then we're doing airline reservation systems. This is good for coupling with our other sister university in San Jose. Great program in administration of airline management and administrative aspects. The rest, the airline operations, can be learned on the site or through a military branch of some sort that has strength in air technology, repair. 8th, we have technology overview. We're going to cover 7 topics. The J2 double E overview, Java server page, Java servlets. We're covering Java database connectivity, Java naming, directory service, Java mail, and application development. 11th. 9th, future scope and development, and you have the future scope and development for the applications, future release of J2 double echo technology. Finally, we went through our references. That's 1 through 16, so make sure you return to the front of the recording to cite the references that are spelled out in front of us. I'm going to go ahead and pick up where we left off. Which, you know what, I'm going to do a second recording. I rarely do this, but this time I will. We're working with list of figures 1 through 6, JSP architecture, MVC Model 2 architecture, servlet architecture, use case diagram, flow of JSP pages, servlet beam interaction. And now our abstract. Study of Enterprise Java Beans by Emmett Ravi, Master of Science in Computer Science, California State University, Chico, summer 2005. Great master's thesis. Very great. Okay, today the internet established itself as an alternative medium of doing business. An increased number of companies are using the internet through enterprise applications to reach customers. So it's becoming necessary to have secure, scalable, robust, and fast applications to serve the wide range of customers spread across the world. Many technologies exist today to build enterprise applications. Java 2 platforms, Enterprise Edition, that's J2 Double Echo. Technology is one of the very most promising technologies to date. Let that be known. Enterprise Java Bean are one of the most important components of J2 Double Echo specifications. They have their own advantages and disadvantages due to the position in the typical tier enterprise applications. But the main focus of my project is to study the EJB components, their design, the advantages and disadvantages of development in the J2 Double Echo server-based applications. More emphasis is given on the understanding of architecture of the EJBs in a traditional application. For this, I've chosen a very familiar airlines reservation management system to replace what current standard base platform that the spread across the airline system is using. Since the government buyout of all the major airlines except for American Airlines, which also needs an updated server-based platform. The fix-it platforms that go on top of that work very well. Really don't need to be replaced, but in the service function and keeping up to date, we'll keep the lower level system, which is good for redundancy and backing up all your work in case the system goes down, in case the computer network goes down. This is fantastic. But in servicing the airline reservation management systems, we're going to come up with Intel has a very complex business rules here. At the same time, is one of the oldest enterprise applications that is still on the legacy system. Accepting the fact that the application is very crucial to business rules, the implementation of complex rules to the left for the future enhancement of this project. Only the very basic required features of the application are incorporated at this time to achieve the main aim of this project. So the main aim of the application uses all different kinds of EJBs, the session, the entity, the message-driven beans. It handles the session management using the session beans. All the database-related transactions are carried out by the entity beans, and the trigger for the entity beans is provided by the message passed by the message-driven bean upon occurrence in a particular event in the application. So that's the abstract. Welcome to Chapter 1. Okay, project overview. Okay, today we're going to show you an increase in number of developments. Want to develop distributed traditional applications for the enterprise and take advantage of the speed, scalability, security, and reliability of server-side technology. To reduce cost and speed up enterprise application design and development, Java 2 platform. That's Enterprise Edition. You'll hear me say Java 2 Double Echo. Technology provides a component-based mechanism for design, development, assembly, and development in enterprise applications. 1. Refer back to the references as I listed at the front of this lecture. Just to throw you a bone, that's R months and half enterprise Java beans. Okay. Why EJBs? Okay, there are a number of websites that demonstrate that it's possible to provide dynamic content using serverless or Java server pages, the JSPs alone, but the JSPs is an extension of the servlet technology for developing web-based applications. Seek out reference 3. Gives this fact. Reference 3 is B Kuranja, that's Kurniawan, Java for web with servlets JSP and EJB. Pull that up, go ahead and type that below. I want to see that's been looked into. Given this fact, it might seem that the enterprise Java Beans, the EJBs, adds unnecessary complexity to the development process. However, the EJBs extend the modular approach beyond the JSPs and the servlets to business layer. They also help separate the roles of the web designer, business logic developer. Furthermore, they provide a reusable component that make them portable, scalable among different platforms and vary requirements. The enterprise Beans is essentially a server-side component written in Java programming language that encapsulates the business logic of the application. Same references before. The business logic fulfills the purpose of the application. Enterprise Beans simplify the development of large distributed applications. There are 3 types of enterprise beans available: session bean, entity bean, message-driven bean. We should think about using EJBs if the application needs to be scalable, i.e. if the application has grown numbers of users and is running off a different machine. Seek reference 4. Reference 4, Sun Microsoft System compatibility. That's J2EE. This is compatibility with Java verification. Okay, second reason for using EJB, number 2. EJB is if the transaction needs to ensure data integrity and the application has a variety of clients. The EJB runs within the EJB container and a runtime environment with the EJ2 double echo server, and the EJB container provides various system level services such as transaction logic to the enterprise beans. These servers make it possible to quickly build and deploy the enterprise beans that form the core transactional J2 double echo applications. Purpose of this project. Primary goal of the project is to study the architecture and deployment mechanisms of the EJB and a J2 double echo application server. The development of the application that implements EJBs will serve to support this intent. Scope of this. Current EJBs 2.0 specifications available from Sun Microsoft Systems. The study of EJB architecture and its design will be limited to this specification. Different types of EJBs will be studied and an application to support the design will be developed. The scope of the project is the study of this new technology. In consequence, relatively less emphasis will be given to the completeness of this application. Welcome to Chapter 2, Architectural Overview. The Enterprise Bean Component. The Java Bean Enterprise has 3 different types. The entity session, message-driven beans. The entity bean is a session. Beans are remote methods invoking the RMI-based components. The message-driven beans are asynchronous and respond to JMS messages. Seek reference 5. I want to see the comments below on the answer to this reference of the Enterprise Java Bean technology in Sun Microsoft link. Let's see. Entity beans represent and persist the data in the database. Sessions being manage different processes or interactions between different entity beans. Typically, they receive their state from the client, and they exist till the client needs them. Seek reference 1. Are Munson-Haffel Enterprise Java beans. Message-driven beans respond and process various asynchronous messages and manage the actions taken by the beans in response to the message. Reference 5. Enterprise Java Beans technology. Seek the Sun Microsoft Incorporated link below. The Sun message-driven beans both represent non-persistent data in the sense that they are transient. Component of a bean. We need to define various interfaces and classes in order to implement a bean. Reference 1. Our Munson-Haffel remote interface. A bean presents the business methods to the outside world to carry out its work. These business methods are defined in a remote interface so that they can be accessed outside the EJB container from the application. Remote home interface. The lifecycle methods to create new beans, to remove and define beans are defined in the interface. The create method initialized an instance of a bean. We can have different create methods with different augments. The find by primary key provides a content way to look up a bean. Reference 1, which is again R Munson-Haffel. These names memorized. Local interface. The local interface of the beans. So the interface defines the business methods. The beans co-located in the same EJB contains use of it. The convention avoids the overhead of distributed object protocol. Okay. We have the local home interface. The local home interface is similar to the local interface used by the beans in the same address space and defines the lifecycle methods. Bean class. Bean class. This class is responsible for actually implementing the bean's lifecycle and business method. It also has a certain set and get methods. Additionally to these methods, also contains a EJB create and EJB post create. So the methods to initialize the instance of a bean class when a new record is added to the database. Some of the methods like EJB remote, EJB load, EJB store, notify the changes in the state of the bean. Primary key, the only entity bean use. The primary keys as they represent the data in the database. The message-driven bean only has the bean class and contains a single method on message that gets invoked when the new message arrives. It either, or neither rather, has a business method nor primary key. Reference 1, R Munson-Haffel Enterprise Java Bean. The deployment descriptions and the JR files. The deployment descriptions server the same function as the property file. They allow us to control the runtime behavior of the software without modifying it. They have the property of the bean and can be created using visual utilities like property sheets, JR files, and used to package various components of the application. Using Enterprise Java Bean. Entity beans represent the data and behavior, but they are not useful for modifying or processing a task. Okay? On the other hand, the session bean are agents to manage a process or task. They implement the business logic and work with other resources by interacting with entity beans. This is how the session bean controls the workflow. The workflow is the geist of any business system. Moving workflow control to the session bean reduces the complexity of the client application and eases network traffic and connectivity problems. One method invocation of the client actually invokes many methods on server side. However, for the network, there's only one method called. This call helps reduce the network traffic. Session beans can also limit the number of stubs on the client side. So moving into the bean container contract, all the beans run a special environment on the server side called container. Reference 1, R months and half enterprise Java bean. A container can be viewed as an interface between the bean and the EJB server. Mainly, containers invoke the callback method when the appropriate lifecycle event has taken place. The bean container contract is nothing but a protocol for communication between the bean and the server it resides in. Okay, the contract simply defines how the EJB server controls the behavior and lifecycle of the bean. The bean has to interact with the EJB container and using the component model. Reference 1, that's R months and half-ol, Enterprise Java Bean Cambridge. 3 main interfaces: Entity Bean, Session Bean, and Message-Driven Bean. These interfaces play an important role by providing callback methods to notify the bean's class about the lifecycle event. Alright, moving into the container server contract. Since J2 double echo is a specification and not a technology such as this contract is not defined in the specification. Seek reference 6, E. Roman S. Ambler, T. Jewell, and Marinsky, Masters Enterprise Java Bean. These are definitely in a need figure generations of EJB specifications to outline this contract. The big advantage to doing this is having different containers that can plug into different EJB servers without any modifications. Reference 4. Compatibility, Microsoft Systems, compatibility and verifications. This would need the vendor to generalize the architecture of the container and servers that could impact the performance. Also, this could potentially question the core competence of the validator. That is R months and half-ol Enterprise Java Bean. Seek that out again. Thus, we saw a typical architecture of the EJB systems and flexibility given by the J2 double echo specifications to the vendors for implementing the EJB servers and the EJB containers. We will seek in Chapter 3 the basic resources and services available for the EJBs. Chapter 3, Resource Management and Primary Services. Resource management. The number of clients accessing the server and the number of distributed objects servicing them are directly related. As the number of clients increases, the number of resources used to service them also increase. In this case, the EJBs, there should be a mechanism to manage a larger number of beans at runtime. EJBs contain archive. This is established by 2 mechanisms: instance pooling and activation. Instance pooling, you're going to find that this idea is similar to database pooling. Reference 1 again. Enterprise Java Bean, R months and half-ol. The EJB container maintains a pool of bean instances. If we do not use the pooling, then every time a request comes, a new instance of beans is created, and then the request is serviced, and the instance gets destroyed. So, compared to the instance of pooling, it's less expensive, and it avoids the need to create and destroy the object's instance frequency. Same reference 1. It also leads to the reusability of the beans. The server does not have to keep a separate copy of the beans instance for its client. The client has no direct interaction with the bean. It accesses the bean through the remote interfaces. There are 3 states of the bean's life cycle in relation to the instance pool. 1, no state. The bean is not yet initiated. It's not instigated. 2, pooled slate. That's S-A-T-E, no L. Sate. The bean is instantated by the container and is waiting to be associated to the object. Thirdly, the ready state. Now you hear the sate. That is a typo. So it's S-T-A-T-E, not slate, not sate, state. The bean is associated with the object and is ready to serve the methods implicated. Okay, instant swiping. Stateless sessions begins. The beans go by one beyond and offer a more powerful feature, instant swapping. Stateless session. The beans do not go. The bean do not maintain its state between various methods and invocations. That is cited in reference 3, the B Quran Java for the web and servlets JSP and EJB. Therefore, the instances can be allocated to the different EJBs, objects that are requested and serviced from the bean. Activation mechanisms. Stateful sessions. Beans maintain the state between the method's invocations. Consequently, they are attached to the bean to the same client until the client is serviced. This state is called the conversational state because it maintains the conversation between the client with the servers and their services. Therefore, the beans cannot be participated in the instance pooling. To conserve resources, the concept of activation mechanism is used in order to passivate the bean, which is defined later in the paragraph. So the bean state is serialized to a second storage and then maintained relative to the EJB object. Upon the invocation of the method by the client, a new state instance is initiating the populated form of the storage. Thus, the activation of this act is restoring the bean's instance state relative to the EJB's object. The passivation of this object just as opposite process of saving the bean's instance state in secondary storage. Reference 1 again. R. Munson Haffel, Enterprise Java Beans. Primary services. In order to complete the EJB platform, the EJB container provides various services termed primary services. These primary services include concurrency, transaction, persistence, distributed object, asynchronous messaging, naming, and security is a foundation. Concurrency. The session beans do not support concurrency. A stateful bean is always attached to one client, so it does not make sense for it to support concurrency. A stateless bean does not maintain a state that needs to be preserved, so even stateless beans do not require this feature. The entity bean is a shared component, so it's required to protect the data encapsulated in the shared bean. That is, the EJB by default does not allow concurrent access to the bean instance. The method need not be made thread safe, as this is taken by care by the EJB server. Also, these methods prohibit the use of synchronous keywords. Reentrance. Reentrance occurs when the thread of control tries to reenter a bean instance by default. The beans here are not reinternated, and the loopbacks are not allowed. Okay. This policy is applied differently to entity and bean sessions. The session beans are never reinternated. So that is back to reference 1. Keep on repeating myself until I see them cited below. R Munson Haffel Enterprise Java Beans. But the entity beans can be made, reinitiated in the deployment descriptor. However, it is discouraged by specifications in the case of German beans. The issue is not relevant as they do not respond to RMI calls. Transactions. Transaction is a set of tasks that are executed as a whole. The transaction is an atomic process. All the tasks, transactions must be completed together in order to consider a successful transaction. Transactions are managed automatically by the server. Persistence. Persistence refers to storing of the beans instances in a database. There are two types of persistence: in-case container message persistence, and the server takes care of the synchronizing the entity beans instance files are filled with the data in the database. When the bean manages its own state and is responsible for storing and retrieving the data from the database, it's called bean management persistence. Okay. Distributed objects. Java RMI is an abstract or programming model for distributed objects developed in the Java language. It is traditionally limited to Java Remote Method Protocol, the JRMP. EJB 2.0 requires the Java RMI and the IIOP, which is COBRA compliant version of the Java RMI7. So RMI, reference 7, which is the Object Management Group Incorporated homepage. This allows the developer to use the simplicity of Java RMI programming model and to take advantage of the platform-independent COBRA protocol termed IIOP. Asynchronous enterprise messaging. Asynchronous enterprise messaging requires that the EJB container effectively route the messages from the JMS client to the message-driven beans. In addition to the message-driven beans, stateless session beans and the entity beans can also send JMS messages. Naming. All distributed objects have to use some kind of naming service. Java RMI, IIOP, and COBRA have their own naming service. It provides object binding and lookup service. I want to see you looking up reference 8, some Microsoft. Java naming directory interface, that's JNIN and JNDI. Object binding is association with the distribution object with a natural language name. Language is an identifier. The binding is a pointer to the distributed object. A lookup service allows the client to connect to a distributed service and to request a remote reference to the specific object for the EJBs. And the use of Java naming directory interface, JNDI, and standard extension to Java platform is compulsory. Security, which is our foundation. EJB servers can support 3 types of security: access control, authentication, and lastly, secure communication. Authentication is the validation of the identity of the user. Access control is what the user can do and cannot do within the system. Most secured server systems support secure socket layer protocol for secure communications. Moving on to Chapter 4, Entity Beans. Entity beans. EJBs are used to present a real-world objects or concepts. The Model A state that is transactional. They provide a mechanism for mapping and the instance variables with actual fields. And the database is storing them in the database, which in terms is persistence. A special type of EJBs is called entity beans. It is used to persist data to secondary storage. Reference here in 3. A for WAN, Java for the web. Will serve its JSPs and EJBs. Similar to the Java classes, we're going to find that even in an entity bean has fields and methodology. Same reference. The Quran, Java for the web, and service JSPs and EJBs. In the case of EJBs, there are 2 types of persistence. If the container takes care of handling all the database transactions, like insert, update, and delete, and query, querying the database is called the container message persistence. Reference 1, R months and half enterprise Java beans. Bean management persistence, on the other hand, gives the programmer the flexibility of handling the database transactions. While it gives more control over the data, it can be more overhead in development process. It's advantageous to entity beans in the sense of accessing the database directly because it's easier to manipulate the data as objects, and it provides a simpler mechanism to access the changed data. The life of the entity bean depends upon the data represents. Seek that in reference 3, be Quran, Java for the integrate serverless JSPs and the EJBs of an entity bean represents. Let's represent the credit card account. Since they typically, a credit card account lasts for many years, the entity bean could also live for many years. So take that for example. For an entity bean, the following files are defined 3. 1, the remote interface. 2, home interface. 3, primary key class. And 4th, the entity bean. And 5th, the deployment descriptor. And as stated earlier, there are 2 types of these entities, beans that are described below. So once again, tell me what those 2 types were. Let's see the comments below. Container messaging persistence. In container message persistence, CMP 2.0, the container message state that the beans automatically, it's responsible for the entity beans and the transactions. It also stores the persistence of the bean state to the database. The persistence fields are defined in the entity class by abstract processor methods and the assessor method. The relationship field can define in the same way. The abstract persist schema represents a set of the XML element in the deployment descriptor that illustrates persistence and the relationship fields. The concrete class generated by the container to implement the abstract entity classes are called the persistence classes. Instances of these classes help the containers read and write data to the database. These classes include the logic to assess the database. The container generates this logic at the same time of deployment and includes the logic in the persistence classes. Therefore, bean developers do not have to worry about writing this logic themselves. Therefore, certain advantages to their container message persists. So the bean can be defined independently in the database. That is for storing the state. The developer can take advantage of the relationship as well. The object-oriented database. The container managed persistence so that it has some disadvantages. Okay, we require that some sophisticated tools map the bean fields to the database, and this can become quite complex in the case of legacy systems. So within your airline legacy database system that you are working on, errors can be forwarded, but the patches can remedy up that issue. The entity bean can have 7 types of relationships, and we can have one-to-one, one-to-many, many-to-one, many-to-many, and cardinalities are Munson-Haffel enterprise Java beans. Then each relationship can be unidirectional or bidirectional. Okay. This gives us 8 different types of combinations. However, bidirectionality, one-to-many, many-to-one, are the one and the same. Okay. Let me repeat. However, bidirectional, one-to-many, many-to-one are one and the same. Don't get those concepts mix and matched. You're going to find it in other texts and references stating the different headers of the descriptor of what I'm talking about. But once again, bidirectional, one-to-many, and many-to-one are one and the same. Cardinality in the direction of the entity-to-entity relationships must be declared in the XML deployment descriptor. Being managed persistence, okay? In the case of being management persistence, you're going to see it referred as BMP. Being management persistence, the developer is responsible for the logic that saves the state of the bean into the database. Okay, the BMP is thus more complex as compared to the CMP, but this allows more flexibility in data handling. This is particularly true when the entity bean accesses data from the different database, and the BMP could be one of the great advantages. One of the vendors does not provide the tools to manage the persistence. This is of great help. Okay, so one more disadvantage of the BMP. BMP is that it can bound to a specific database type, and the structure and any modifications in the database leads necessarily to change in the bean code. Seek out the R Munson-Haffel enterprise bean below. I want to see that you have. Let's go ahead and state it below. Even if we select any type of persistence, there are certain things we must always do when we go about implementing these entity beans. We need to have a remote interface that defines the business methods used by the client application. When we require a remote home interface that is used to create, locate, and remove objects from the EJB system. In case of the EJB 2.0, okay, we have 2 types of interface, e.g. local and home interface. Okay, we also require that you have a prime key class. That has attributes that can help us locate the bean in the database, and we must go to have the actual bean class that implements the business logic. This also provides the lookup facility and resource connections for that database. The EJB 2.0 came up with a standard query language called the EJB QL that provides facility to declare find methods and select methods. It is similar to the SQL, but is made to work with the abstract persistence schema. Morning, gentlemen. The queries are defined in terms of the schema and not the data. Therefore, the queries have advantages of being portable across the database schema. When the container deploys the bean class, EJB's QL statements are translated to the data access code at runtime. They get translated into native language of the database. The EJB QL has some limitations. At present, the EJB QL does not support the very important order by clause reference 1, which is R Munson-Haffel Enterprise Java Bean.
That's the best thing ever, man. That's the best thing to work with. When everything's hella slow.
Okay, it allows the programmer to request the order list in the predetermined fashion. But, due to some problems, order by clause is missing from the EJB QL. Another noticeable Exception is that support for Java .util.date class is lacking. Alright. In addition to this, various function expression like count, max, etc. are also missing. Thus, we discussed various features that BMP and create CMP and the advantages and disadvantages using them. It really depends on how the application, whether to go for the CMP or the BMP. Okay, there cannot be any kind of fast rule for that. The choice, however, can be decided by if the application of the database is intensive, involving a large number of tables or a large amount of data being stored in them. Okay, in Chapter 5 sessions, beans will be explained further. Fear not.
There are hella people there too using a
Alright,
shit.
Chapter 5, Session Beans. As the name suggests, a session bean is used to represent a session in the application, hence it gets tied to a particular client during its life cycle. Therefore, this is used in describing interactions between other beans. Unlike the entity bean, these bean session beans do not represent the data in the database, although they can access the data. Seek 3. Which is B Kurwan, that is Kurnia Quan, Java for Web, Servlets, JSP, and EJBs. Want to see that listed below. Session beans are present, and the data that spans the concept and therefore are not shared. Offend these beans are used to manage interactions between various types of entity beans. The session bean is initiated, however, and whenever a client asks for these services. Typically, the containers kept in session beans is ready for pull after they've served a client. So, whenever the next client asks for the services, they can be quickly served. So the client doesn't have to fear whether or not you can get the job done, and once that seed is placed, you can go ahead and correct the issue. Toot sweet. There are two types of session beans, stateless and stateful. Like I mentioned before, stateless session beans. A stateless session bean is a group of related services, each representing a method. Okay? During different invocations, the bean does not maintain the state. It executes the method and returns the value. It is stateless. Let me repeat. Executes the method and returns the value. That is stateless. Okay, remember that. It's going to come up later. Because it does not care what other requests have gone before. Developing the stateless bean is comparatively quite simple. Stateless session beans are neither persistent nor dedicated, okay, to the client, so they take very few resources. That's stateless. Makes sense, right? Okay, many EJB objects can share a few instances of stateless session beans. Such stateless session beans do not maintain conversational state, okay? So they can be swapped between different EJB objects. Their services are generic and reusable, okay? Once the method is invocated and is executed, the return values is passed to invoke object and nothing is remembered, okay? It's generic and reusable. So after which the beans get ready for the serve to the next client. This does not mean that the stateless session beans cannot have instance variables or cannot maintain the internal state. Can you tell me if that is stateless or stateful? Okay, it does not mean that the state is never visible to the client, and the instance variables will have different values for different clients. Let's see if you looked it up in reference 1. Are Munson Halfel enterprise Java beans? Therefore, we cannot assume that the same bean instance will serve the same client. And the next time it is served, various applications of this kind of the beans are reported. They report generations, the batch processing, or the credit card verifications. Once again, found in R. Munson-Haffel Enterprise Java Beans. Okay, the life cycle and stateless session beans. The life cycle of a stateless bean has two states. It does not exist and method ready pool. When the bean does not exist, this means that it does not instantaneously generate a memory protocol. And this is the method ready pool. Is equivalent to the instance that the pool of entity beans. The bean enters a state when the container needs it. Okay? The EJB server may create several instances of these stateless beans and enter them into a method ready pool. When the state number of stateless beans is insufficient, okay, that means they cannot be created and added to this pool. When an instance makes a transaction, it does not, and I say it does not state to method ready pool. Basically, there's three operations and can be carried out on the last bean instance. That is reference 1. Once again, I want to see that you looked up these three references. R. Munson-Haffel Enterprise Java Beans. Okay, first, we have bean instance and initiated. Second, we have the bean instance received is referenced for the lifetime. And third, we have the EJB create method is invoked to complete its creation.
Good morning. Hi.
Morning, hi.
Go ahead.
I'm for the Express.
Oh, hi, how you doing? Franklin Nolan.
Oh,
Pleasure to meet you.
yeah. She needs your first and last name.
Yes. Can I? And your
And what is
major?
you need your book out. To write his first and last name. Make sure you have the correction, the spelling of it. The spelling of it.
Franklin Nolan.
See. No, you can write it. You want me to write it?
I'm in the middle of presentation here,
Oh.
so
Oh,
it's
okay.
What is your
Trying to
what is your
speed this
major? Okay. What is your major?
computer science.
Okay, and are you a senior, freshman, or junior?
I'm a transfer student.
Oh, okay, transfer student from where?
From where?
Yeah.
Well, I don't disclose my
Oh, okay.
transcripts.
Okay, just transfer student. Okay, thank you.
I'm just gonna take
And
one
so
more
can
shot.
everyone
Look at
else.
it.
Don't do it.
Yeah, I
No,
need to do.
no.
Here we go. So,
Oh yeah. No, I mean you can't look at me. It's okay. Thank you.
all right. Have a good morning. Okay. Moving forward. We're still talking about session beans, stateless and stateful. And we left off at the life cycle stateless session bean. The life cycle of this stateless session bean has two states. Does not exist and the method ready pool. When the bean does not exist, this means that it cannot initiate in memory. Cannot be initiated, instantiated in the memory. Okay. The method ready pool. This is equivalent to the instance pool of the entity beans. This bean enters the state when the container needs it. The EJB server may create several instances of stateless beans and enter them into the method ready pool. When the number of stateless beans is insufficient, they can be created and added to this pool. When an instance makes a transaction from the does not exist state to the method ready pool, basically 3 operations are carried out on the bean instance. Seek reference R. Munson-Happel Enterprise Java Bean. First, we have the bean instance is initiated. Second, the bean instance received is reference for the lifetime. And third, the EJB's created method is invoked to complete its creation. Stateful session beans. This type of bean can be viewed as an extension of the client application. It is used to perform the task of the client to maintain a conversational state with respect to the client. Methods invoked by this can be read or write data to database. The main difference between the stateless bean and the stateful bean is a stateful bean does not use the instance pool. Stateful sessions are normally used to capture the business logic that is found in the second tier of the 2-tier application. It is dedicated to one client for the life of the bean instance. The second swapped among the different EJB objects or kept instance pool like entity or stateless session beans. 1. Let's reference 1 again. R. Munson-Happel Enterprise Java Beans. Okay. When we initiate a stateful session bean in the instance to the EJB object, it gets dedicated to the object for its entire life cycle. As it maintains the conversational state of one method invocated, it affects the result of subsequent method invocations. Each method invocated request is fulfilled by the same instance of the bean, reference 1. R. Munson-Happel Enterprise Java Bean. As it gets attached to just one client, its states can be predicted, even though the stateful session bean maintains the conversational state are persistent like any entity beans, reference 3. R. Per 1, Java for the web with servers JSP and EJB. Why does everyone feel the need that to interrupt you? Because they want to move on. Okay, obviously, they concurrent access the stateful session between beans is not allowed. Such beans can access data, but it does not represent any data in the database. We can move some of the business logic and encapsulate it to the session bean. It thins the client and makes it easier to manage the system. Next, we have the life cycle of the stateful session beans. Stateful session beans do not use instant pooling. They are dedicated to one client all the time. Excuse me. In other words, there's no swapping or pulling of the instance. Therefore, these instances are not pooled but are thrown out of the memory just to conserve resources. The EJB's object still remains connected to the client, but the bean instance is garbage collected. It becomes important to passivate the bean instances to preserve the conversational state of the instance. The bean instance must be activated to restore the state when EJB is active again. The life cycle of the stateful session bean has 3 states: does not exist, method ready, and passivity. It is passivated. First 2 states are the same for the stateless session. However, third state is different during the life cycle. The beans are there may be interactive periods when the bean instance is not servicing the client at that time. The container may passivate the bean instance and evict it from memory. When the bean is passivated, the instance fields are ready and written to secondary storage. When this process is completed by the bean is destroyed, the process of writing to secondary storage is called sterilization. See reference 9. Microsoft Systems Java 2 Platform Standard Edition J2 SE Java Technology. The containers can be used as different methods of sterilizations than Java sterilizations. They can simply read the values and then put them into the cache. In the case of sterilization is used, the same rules are followed for activation. Activation is the opposed process of passivation. The container sometimes moves the bean instance from the passivate state to the does not exist state of the bean times out. Reference 1. R. Munson-Haffel, Enterprise Java Bean. In this chapter we saw 2 types of sessions, beans and their life cycles. Chapter 6 we will explore the message-driven beans and their life cycles. Chapter 6, Message-Driven Beans. Therefore, any discussions about message-driven beans, MDBs, and its importance to have knowledge of the Java Bean services, JSM, that is reference 10. Microsoft Systems Incorporated, Java Bean Messaging, JSM, Java Technology, J2 Double Echo. Okay, just like the JDBC, the JMS is also a vendor-neutral API used to provide access to enterprising messaging systems. Reference 1, that's R. Munson-Haffel, Enterprise Java Bean. We have MDBs make use of this JMS. Each EJB container comes with a built-in JMS provider. Various enterprise products have supported JMS. These products include IBM's MQ series, BEAs, WebLogic, JMS services, etc. All these applications using the JMS app, the AIP for message exchange, portable, and that is R. Munson-Haffel Enterprise Java Bean. One important advantage of the JMS messaging is that it is asynchronous with this in nature. This means that the JMS client need not wait for a reply when it sends a message. This is exactly opposite of the Java RMI. The client can obtain a JMS connection to a JMS provider using JNDI naming context. A message can be sent to the destination by 2 prominent methods, topics or queue. Okay. A typical JMS application is comprised of many JMS clients and at least one JMS provider. A JMS client can send and receive messages simultaneously. A producer is a JMS client that sends a message while consumer receives the message. all enterprise beans can send a message using JMS. Normally, Java applications or MDBs process these messages. A message is sent to a destination that can be either a queue or a topic using a message broker or a router. In case of destination is a topic, we need to make connections using Topic Factory. See reference 1, R. Munson-Haffel, Enterprise Java Beans. Okay, then we need to establish a session and to create a publisher that publishes the message into a particular topic. Topic, as I said earlier, is a network-independent destination. Okay, a JMS client that receives the message has to subscribe to a topic. The JMS message has two parts: a header, a message body. A header consists of the metadata and delivery information, and the message body contains the application data. The message can have different types such as text message, map message, object message, etc. This particular messaging model is called the publish and subscribe model, and is modeled. In this model, there can be subscribers that will listen to the same topic. And the other types of messaging model is called a point-to-point. The P2P model, reference 1, again, is the R. Munson-Haffel Enterprise Java Bean. In this model, there are only there's only one sender and one receiver, okay? One sender and one receiver. The destination of this type of queue, a queue can have many receivers, but only one receiver receives each message, okay? The JMS messages are asynchronous in nature, meaning so that the entity in the session beans should not be used to respond to these messages. The entity session bean holds up to the resource until they receive the message. This is not desirable feature, so the MDBs, the message-driven beans, are designed especially to take care of the messages. Okay, message-driven beans, as stated earlier, the message-driven beans, the MDBs, are specifically designed to process asynchronous messages on the server side. They are stateless as they do not require maintaining the state of fair process. The message 1, the R. Munson-Haffel Enterprise Java Bean, are contained, takes care of anything for MDB, including transaction security. MDBs can process and consume messages simultaneously. The MDBs can have many instances running so they can process all the messages concurrently. Okay, one of these differentiating features of MDBs is from entity.
Hello?
From entity and session beans is the absence of component interface. These interfaces are absent because MDBs respond to asynchronous messages only. Every MDB class implements Java x.ejb message-driven beans interface that defines the callback methods like entity and session beans. MDB instances are used process messages from various clients. These instances try to a topic or to queue from which they get the message, so they don't get tied to the JMS client. Hence, they are stateless. Like stateless session beans, every MDB class also has to implement Java x.ejb message listener interface. It also has on message method where about the business logic is kept. The life cycle of a message driven bean, moving into the life cycle of a message bean. Any MDB message driven bean has two states: does not exist and the ready pool. Okay, when the MDB does not exist, the state that means is not initiated. Okay. When the server is created, it creates some instances of MDBs and keeps them in a method-ready pool. Creating more instances depend upon the number of incoming messages, and that server can create more instances and then pool them. Okay. When any of these messages are delivered, it gets delegated to one of the available instances in the ready pool. At one time, the instance can process only one message. When the processing is completed, to get ready to its new message handler. Thus, the MDBs, the message-driven bean, are message-driven bean. Okay, at a time, one instance can be processed, one message only at a time. When the message is completed, it gets ready to be handled to the new message handler. And to handle pass, how are we doing on time? Oh, we're good. Alright. Every MDB class must the java.xjb message-driven bean interface that defines the callback method like entity and session bean. The MDB instances are used to process messages from various clients, and these instances get tied to a topic for a sequence from which they get messaged, so they do not get tied to JMS client. Hence, they are stateless, like session bean. Like stateless session bean. Okay, these instances get tied to a topic or a queue from which they get a message, so they do not get tied to a JMS client. Hence, they are stateless. In stateless session beans, every MDB class also has to implement the JMX. Getting out of the sun. All right. Alright, message listener interface. It also has one message method, on message method, where all the business logic is kept. Life cycle of the message driven bean. Any MDB has two states, does not exist, and the method ready pool. Got nothing for you this time, Chip. Alright, the life cycle of the message-driven bean. Any MDB has two states, does not exist, and the method-ready pool. When the MDB is in a does not exist state, this means that it is not initiated. Okay, when the server is first created, it creates some instances of MDB and keeps them in a one method ready pool. Okay, the server can create more than instance and then add them to the pool. When any message is delivered, it gets delegated to one of the available instances in the ready pool. At a time, one instance can process only one message. When the process is completed, it gets ready to handle new message. Thus, the MDBs are effective way of messaging exchange in the enterprise application. Their main use in the case of EJBs in my application, I have deployed an MDBs to pass on the message from the session bean to an instance bean upon particular event. MDBs get their own trigger when this event occurs. It gets invoked by a method in the session bean. This bean is called a method in an entity bean that retrieves or stores the data. In Chapter 7, we will actually study the airline reservation system in detail. Taking a break, we'll move on with Chapter 7, Airline Reservations. This is Associate Professor Franklin Nolan, covering the studies of interface Java beans by Amit Ravi, summer 2005, master's thesis, California State University, Chico. This thesis can be found at QA 76.bravo4928, 2005, and the barcode number is as follows: 3 space aught 2 double aught space aught 16 double aught space 6603. Today's date is September 18th, 2015.